Meanwhile, I will talk about new signal processing libraries for Faust. So, why new signal libraries for Faust? Because they are old Faust libraries now. So I don't know if many of you here have been using Faust a lot, you know, so those are what people have been using for many years now, which doesn't really exist anymore, you know. But so in the past, there were kind of two classes of libraries. There were the libraries that were maintained by GRAME and people at GRAME, and then there were libraries that were mostly made by Julius Smith at Stanford, and so libraries were kind of developer dependent to some extent, you know, and not that we were getting that many contributions for DSP stuff that were ending up in libraries, you know, but we kind of thought that this paradigm was getting a little bit hard to understand by new users, basically, you know, because music.lib, even though it's called music.lib, also implemented filters and implemented things like that that were not in filter.lib, you know, like, so the whole thing was kind of getting a little bit messy. So last year, we decided to reorganize everything to provide more libraries with better names, as well as documentation for the libraries. Wow, documentation. That's which we didn't have, and which actually is pretty important, especially for new users. By the way, I just want to mention that Julius published a paper for this conference in 2012, where he kind of introduced the content of those libraries, you know, which is now in the new libraries. So things changed in terms of the organization in general, but the content is kind of the same. Even though, because now we have a much better, a much nicer framework to for new development to happen. You know, like there are actually many new contributions that happened since the new libraries were put in place. But and I will talk about that. So now the new organization of all this, you know, kind of looks like this, and I will go into more details later just to show you the content of the library a little bit, you know. But now we have analyzers.lib, basics.lib. Basics.lib has all the basic functions. We have a library of compressors, and I'm not sure if yours made it yet to it, but eventually.
Recently got to compile, got the new Faust version.
Oh, really? Okay.
Working on it.
Well, anyway, so I mean, there is a compressor library, so your stuff, for example, should go in there. Like that's and that's like the whole point of having this now. You know, like so we have a library for delays, demos, has functions that implements a user interface, and I'll get back to this a little bit later. We have a library for envelopes, a library for filters, a library for mathematical functions, library for different types of effects that don't fit in other categories like the compressors, you know. We have a library for noises, oscillators, phaser and flangers, reverbs, routing, for dealing with signals, for specialization, for synthesizers, and for virtual analog effects. So we're trying to basically reorganize everything so that the whole thing is a little bit more segmented, you know, and we're still adding new stuff, you know, and new libraries, you know, and so. I'll show you a little bit the detail of the content of the libraries later in this presentation. But before I do that, I just want to talk about a few stuff. So a new thing that we have is this new meta library, which is called STD Faust.lib. So from STD Faust.lib, you actually have access to all the Faust libraries from one single point. You know, like, so now all you have to do is to call STD Faust.lib. Okay, And then you have this prefix system that you can use to call the functions that are implemented in the different Faust libraries. So for example, to implement this Faust code in the past, what you had to do, is that you had to import oscillators.lib and you had to import filters.lib to get access to the sawtooth wave and to the Butterworth low-pass filter. Now, you only have to call stdfaust.lib, and you can use this prefix here to get access to all the oscillators, and this prefix here to get access to all the filters, so Julius kind of started this way of dealing things in his own libraries, and we thought it was kind of a nice way to approach all this, and we decided to spread it to the new Faust library system. However, if you don't like that, you can still use the old system and import the libraries by hand, and this should not break anything. Additionally, there is also an old.lib, which works in a very similar way because there is no name conflicts in the new Faust libraries, which was not really the case in the previous one. There were a few things, that were a little bit redeclared in some places. We don't have this problem anymore. So as a matter of fact, if you don't like to have prefixes, you can just call all.lib, and now you have access to all the Faust libraries all at once without using prefixes, but I think that's a little bit more elegant to some extent to use this system here. By the way, the reason we did that, was mostly for backward compatibility reasons, because some people here have some pretty serious pieces of codes. That are implemented in Faust, and when we switched to the new Faust libraries, they were like, ugh, and like Albert had like multiple heart attacks that week, and so to make things a little bit easier, like for people who were not ready to move to this, and just rewrite everything, that's kind of the solution we came up with, to minimize the amount of work to do to make this backward compatible. Which brings me to the topic of backward compatibility here, because backward compatibility was very hard. It was very hard, because we changed so many stuff, that it was impossible to make things backward compatible, So as a matter of fact, if you have a piece of Faust code that you wrote 2 or 3 years ago, and you try to compile it with the latest version of the Faust compiler, it is very likely that it's not going to work. So we couldn't really change anything without breaking things, and so what we did is that we did that, and then we still give access to the old Faust libraries. So those, but we deprecated them. So now whenever you use those, you get a warning from the Faust compiler which tells you, like in a very Apple fashion to some extent, just tells you, well, yeah, this library is deprecated, so don't use it. Now, to prevent name conflicts between the old libraries and the new libraries, because we still try to provide backward compatibility, we had to do this funny thing where, I don't know if you noticed, but all these library names here are plurals. And so that's the only way we found to solve this problem, basically. Because, for example, which one? Yeah, oscillators. So there is an oscillators, .lib, and there is an oscillator.lib, right? So that's the it's kind of dirty, but that's the only way we found, to not break everyone's code, and it works so far. So far, so good. Plus, if you write new code, you should use the system, which you don't have to think about library names anyway. So yeah. There is this nice feature now that libraries are automatically documented using a markdown system which is used internally within the libraries. So if you look at the new libraries code, all the comments are written in markdown, and we wrote this script which is Faust to markdown. Faust to Markdown take a Faust code, looks at whatever is written in Markdown in it, and then converts it to a Markdown file, which then you can compile using Pandoc into a PDF or an HTML file or something like that, which is pretty nice. I talked about backward compatibility. Before I just keep moving on this, I just want to give you a brief tour of the Faust libraries. So, just to show you a little bit the content of them. By the way, if you go online and if you look for this webpage, this is how the new documentation for the Faust libraries looks like, and so this file is automatically generated from the new Faust libraries. So if you have Faust on your computer and you want to generate that, you just have to say make doclib, and you will get this nice HTML page based on whatever documentation is written within the Faust libraries. Okay. We wrote some stuff, about new contributions, because once again, the whole point about this is kind of to force people potentially to contribute a little bit more to that. We have a fair amount of contributions in Faust in terms of new architectures or new targets or whatever, but we have less people who who add stuff to the libraries, and hopefully this system kind of makes it a little bit easier and a little bit better. So at the beginning of the documentation, you have the list of prefixes that you can use to access the different libraries and their different content. Now, one thing that I want to point here, which is kind of a new feature as well, are the standard functions. So for those of you who've been using Faust for a while, you know that if you look at filters.lib, there are a lot of filters in filters.lib. Because when Julius Smith wrote the library, he was like, okay, I'm going to try to implement all the filters that I know, and that's what he did basically. So there are dozens of filters, and there are like dozens of low-pass filters, for example, and when I teach workshops for Faust, often people are like, okay, it's kind of hard when you're not an expert in signal processing to know which low-pass filter is the good low-pass filter, like the actual low-pass filter, So to solve this problem, we created the standard function system, which is documented here, where you have different sections. So you have analysis tools, basic elements, conversion tools, effects, envelope generators, filters, oscillators, and sound generators, and synthesizers. And here we kind of give you access to the more standard, not so esoteric filters or functions that are available in Faust. If we look at effects, for example, here is the Ottawa, the compressor, the distortion, the crybaby, which is much more legible, than a cubic NL, for example, which if you're not an expert in signal processing, don't really know what this really corresponds to, So we really try to do some work with that, and all these things are done automatically, So it's very nice. You just have to tell the Faust documentation internally, that those functions, that a function in particular is a standard function, and will get automatically added to that, which is pretty nice. Filters, now you have just com filters, low pass Butterworth, low pass resonant, So I think this is much more legible than the old format, Yes. Now, just to give you a brief tour of the libraries. Libraries are now organized in sections. So there are sections within libraries, so things are better organized than they used to be in the past. So for example, analyzer, .lib doesn't have much, but if we go in basics .lib, you will see that conversion tools are all organized in one section, counters and time tempo functions functions are also organized in one sections, etc. I'm not going to go through all these things, because it's the end of the day, and I'm tired of talking a little bit, and you guys probably just want to hang out and have a beer after that. So I'll probably just go a little bit faster on that, So compressors, we created compressors.lib actually mostly because of you, Bart, because we knew that you were going to make contributions for that. So it's ready for your stuff to come, and so because currently, well, we have a bunch of compressor functions, but this is and limiters, but this is pretty limited, like sorry, and so more stuff are going to come here. We have a master student at Stanford who's also working on compressors these days, so more of his stuff are going to end up here as well. Delays, yeah, etc. No. I mean, I think the best way at this point for you, to see all these things is just to go in there, and check it and look at the documentation, and especially I think look at the new standard functions. I think that's like a very new, nice feature, especially if you're starting with Faust. Okay. So evaluation and future directions for this. Last summer I taught a Faust workshop at Karma like every year, and these guys were kind of the guinea pigs for this new thing, and so far, things work pretty well. The standard function thing really helped a lot, because I didn't have all these questions of people, who've been using MaxMSP or PD forever, and who are like, how do I make a low-pass filter, and so I think that really helped. We are still fixing bugs, because there are bugs, and there are especially bugs in the documentation, typos and things like that, because basically when we did it, we spent 1 month just doing it, and just like shuffling everything's around, and writing doc for all these things. And so, when it's the end of the day and you've been typing documentation, you know how it is, that's you make more typos. So there are typos. If you find one, please let us know. We can fix them and correct them very quickly. There are a lot of new stuff now in the library. So compared to what was presented in previous years, there are many new functions that are now available. One of them, which is not a small one, is this new library, which is called physicalmodel.lib. Where is it? physmodels.lib. So that's kind of new. Physicalmodels.lib is a new, it's not just a library, it's almost like a new environment on its own, basically. So physicalmodels.lib allows you to implement physical models of musical instruments using very high-level functions. So it allows you to create bidirectional connections between different elements. So you can really say, okay, I want to plug a clarinet mouthpiece to a tube, to a bell, to a violin body, or something like that. You can really do this now with physicalmodels.lib. So that's kind of a new feature. We haven't published anything about it yet. We haven't announced it as well, because those things are also still being beta tested, but as you can see, they are available, So if you're curious, you should just go check that out, and there are some pretty good stuff, I think. So they are, especially with the electric guitars, and clarinet instruments are nice. So we basically completely rewrote the Faust SDK using this system, and so if you're interested in physical modeling, I think it's really worth giving it a look. We probably plan to divide filters.lib into some sub-libraries, because filters.lib is still very, very big, and we think that we can, divide those things in a better way to some extent. And I think that's pretty much all I had to say. Oh yeah, there is a workshop this summer at Karma, don't forget. But thank you very much, and do you have any questions? Albert.
I just wanted to ask you about the new physical modeling stuff. I remember these operations, you haven't shown them now, but I've seen them before, for creating these bidirectional connections, which is very convenient because that's not easy to do in plain Faust. So was that implemented in with macros, or how did you do that?
No, so let me show you. So this is all very well documented, by the way. So if you go on my website, there is like all the doc for all these things, you know. But basically, everything is based on this new function which is called chain. Okay, and so in chain, okay, there we go. So in chain, you can plug bidirectional blocks together. And the way bidirectional blocks work is that they have 3 inputs, 3 outputs, okay? The first inputs corresponds to left-going waves. The second inputs and outputs corresponds to right-going waves. And then the third inputs and outputs are used to bridge a signal to the end of your algorithm, which is very important because, for example, if you make a string physical model and you want to be able to control the plucking position on the string, you want to be able to, or to retrieve the sound at the middle of the string, like on an electric guitar, for example, where the pickup is somewhere at the middle of the string or like 2/3 or whatever. Then you want to be able to retrieve the signal like somewhere within the algorithm. So that's why we have that. But if you go. If you go on my website and if you go in Faust tutorials, and if you go in making physical models of musical instruments with Faust, there's like a whole tutorial on how to do that. And yet, so there we go. That's like the bi-directional connection.
The question actually was how it's implemented. Is it the rewriting?
Oh no! It's all written in plain
functions.
No, it's all written in plain Faust. Sorry. Yeah. No, it's all written in plain. It's all written.
No, yes, it's using term rewriting. Yes. Yes, exactly.
Sure.
And term rewriting pattern matching is a feature contributed by Albert in the Faust compiler. It's the world-known specialist of Faust pattern matching.
Sorry about that. Yeah, that's yeah.
Since I have the mic, I would just make a quick comment. The fact that Romain told us, okay, I'm going to document the libraries. And it disappeared for 3 months, and then we had the new system of everything rearranged and all the code documented, and now we have the automatic system of documentation so that you can just, if you contribute to the library, for example, just also contribute with a specific way to format the comments, and the automatic documentation with, like Doxygen, so to speak, extract the comment and add that to the website and the documentation. So he did a fantastic works, and I would like to thank you again for doing that. It was really impressive.
Thank you, Yann. Yeah.
For people who are going to the Museum of Art and Industry, don't forget to see and to play with the virtual harpsichord made with Faust at the CIEREC at UGM 3 years ago. So there is a harpsichord that you can completely modify interactively.
Without using a hammer.
So 2 questions. One is, I noticed right before I came here, there's now FFT in the libraries. What can you tell us about that? Because I thought that I don't know enough about the maths, but I understood that you need oversampling for that.
That's a very good question. So Julius recently implemented an FFT algorithm in Faust. I think he mostly did it for teaching purposes, you know, like because actually the way it's implemented in Faust is relatively legible compared to other programming languages. So it is there, you know, and it's and you can use it, but it's probably going to be very slow, basically. You know, like that's so it works. It's fine. I haven't really tried it in real time, but yeah, I mean, like the limitation of Faust, you know, like to not be or not yet being multi-rate, you know, is doesn't prevent you from implementing the algorithm. It just prevents you from implementing it in a way that is usable in real time effectively, basically. So yeah.
And then the second question is, I just noticed there's also a FOF oscillator. At least it's in the documentation, but with a quick GitHub search, I cannot find it. It's just, again...
That's a good question. Okay, where is it?
Yeah, there it is.
No. It's not... No. So that... So basically, that's the description of this section, okay? This is not a FOF synthesizer. This synthesizer here is using filters and pulse trains. So there is actually, or unless there is another one. Is there another one that I missed? No, there we go. Yeah. So basically, see, that's like a section of the library, okay, and that's the documentation of the section of the library, which is very limited, very succinct. But so you know Mike. Mike, I forgot his name. I know you guys talk together. Mike, well, he's a student. Olson, thank you. Mike Olson is working on FOF in Faust, you know, and I think you guys exchanged some emails at some point. I remember on the mailing list, and so when I wrote that, you know, I put FOF here, knowing that Mike was going to add his stuff at some point, you know. But if you go in vocal synthesis here, all the vocal synthesizers that are implemented here are just using pulse trains and filters, or maybe it's not pulse trains. I think it's sawtooth wave or something like that, but it's just like source filter paradigm. There is no FOF implemented yet. I think Mike is working on it because I think he's not taking any class this quarter, and he's you know, maybe it's going to be there next week actually, you know, like right. So. But it'd be nice to have your stuff as well. I mean, that's
yeah, because I made something based on his old implementation, and
sure.
I still need to look at his new, because he has a new implementation now.
Yeah.
Yeah, okay. Just
absolutely.
Okay.
You know, like once again, like the whole point of having this new library system is that contributions should be made easier by everyone. You know, like so if you're like, oh, I have this thing, I made it, I don't see it in the libraries, you know, then you just tell us, you know, and we just throw it there. You know, like that's and now that everything is automatically generated, you know, and all synchronized, you know, like whenever you add something to it, it will end up on the website right after that, you know, and so you know, like, yeah, please just you know our way. So yeah.
Cool. Okay, thank you, Roman.
Thank you.